Next time, if I forgot to start recording, please inform me. Right. So what will happen if I were to do something like this? Let's say you have the microphone. Assume this is the microphone and another microphone. Let's say FM mic or something. And you have the Zoom link. And it is, you have the laptop, another wire coming from this one, microphone here, another microphone here. If you connect them all together directly like this and put it into the amplifier, what do you think is going to happen? If you just connect all the wires together, නිකම wire ටික කට කට ගහනවා. amp එකෙන් එන input එකයි mic එකේ input එකයි sorry amp එකේ නේ computer input එකයි FM output එකේ input එකයි desktop mic එකේ input එක ඔක්කොම inputs ටික අපි එකතු කරලා මේ ටිකට යට ගහනවා. එතකොට මොකද වෙන්නේ? So what will happen if we do it like that? Think. හිතන්න බලන්න. Hatham, what do you think? මොකක් වෙයිද?
Since there are several sounds, there can be a noise.
Yes, there can be a noise. And the other thing is, if you look at this circuit, most of these devices are designed to function something like this. Let's say if you look at a condenser mic, you have one line going like this, other one is connected to the ground or something. And it's between these two lines that you have this voltage. The voltage is between these two lines. That is what it is usually designed to do. So one terminal should be connected to the ground plane. Other one is the one that has the output or the relative voltage change. Now what will happen is if you connect several other things into this particular circuit, instead of ground, let's say you connect it to an output of a PC. So this is the PC output. Now what's going to happen is this might not be ground itself, right? This might have a voltage itself. So that voltage will interfere with this input from this particular mic, right? So then you have an issue because one instrument is interfering with the other because they are directly connected. Maybe this if this voltage is high, the current might actually go into the microphone like this. Now that will be a big issue because this one is not designed to absorb current, right? It can even damage it. Even if you don't damage it, there will be a problem with the quality. Right? So that means we have an issue. One equipment, a signal from one equipment can interfere with the other. So we need a better way to add these signals. So that is where this op-amp circuit known as a sum-in amplifier comes into play. Now let me quickly show you what the sum-in amplifier circuit looks like. So you have this op-amp. Let's say you are using non-inverting input here. You have several inputs connected to, let's say, resistors like this. So this is V1, V2, V3. For the time being, let's say all these resistors are equal. Then this terminal is connected to the ground. Right? In this case, what do you think is going to happen? මෙහෙම කළොත් මොකද වෙන්නේ? Okay, we'll draw a full circuit then with the feedback itself, and I will ask you to write derive the expression. Yes, the mouse. Minus, positive. Why is that? Okay. Now I want you to derive an expression for the V out. Okay. What is the value of V out? Using golden rules, can you quickly write an expression for it? කරන්න බලන්න ඉක්මනට මේකේ පාවිච්චි කරලා මේ circuit golden rules පාවිච්චි කරලා මේ circuit එකේ V out එකට expression එකක් ලබා ගන්න. I'll give you 2 or 3 minutes. If you finish, you can either share the screen, or if you have written it using a piece of paper, you can show the piece of paper, whichever is fine. Try කරන්න බලන්න.
So shall I share it?
Harini, yes, you can share. I can't still see it.
I can't share it.
Okay, okay. Now can you give a try?
Okay.
Okay. In my that is correct. In my question, I gave all the resistors as equal. In that case, you can write another line simplifying it further. Can you write that as well? Sam, what about you?
So I completed. Can I share?
Sure. Okay, one minus. Right. Your answer is correct, but you are skipping some steps, right? Skipping in the sense maybe you have done it in your head. For example, how did you remove the V minus, or in other words, that voltage at the inverting input? How did you remove that one?
I did it in the paper.
Okay, okay, okay. I
I
got it.
removed it.
That means you equate it to the non-inverting input, which is 0 volt. Then it's okay. I thought this was the only thing that you have done, but probably you have done it in paper and did it. Right. Uh, Both of you are correct. So the idea is, see whether you can use this one at least. So the idea is, if you have a circuit like this, let's say this is the V out, this is the inverting and non-inverting, and you have different voltages. Assuming all these resistors are equal, you end up with an expression V out is equal to V1 plus V2 plus V3, right? Anyone having problems how to find that one? Right. Why do we need to use it like this? Why can't we just add the signal? We learned that if we directly add the signal, they can interfere with each other, right? Some signals can go in the opposite direction, right? But using this way, it is possible to add the signals. So what is the difference between this summing circuit and the one that you have learned earlier? Not the learn that I have mentioned, just connecting the wires together. So why this one is more accurate or more efficient or more practical? What is the reason? නිකම්ම කනෙක්ට් කරනකොට මෙහෙම එකක් කරා කනෙක්ට් කරන එක මොකද්ද වාසිය කොහොමද වෙන්නේ?
ඔෆිස් එක එතනතොර වෙන ඉන්පුට් එකක් තවත් ඉන්පුට් එකට යන්නේ නැහැ නේද?
ඇයි යන්නේ නැත්තේ?
අතන 0 නේ මැද වෝල්ටේජ් එක.
That's correct. Because this particular voltage here, where can I change the colors? What is this colors? Yes. This voltage here, if you look at it, it's actually 0 volts. Why? It is equal to this voltage and this voltage is 0 volts. So we are basically having a circuit something like this. So for the first input, V1, the signal directly goes, it feels like the signal directly going into the ground. There's no other voltage fluctuations at this particular point. This one is fixed to the 0 volt. No fluctuations, so it's not going to interfere. Okay? This is called a virtual ground. So using that method, you are able to make sure they don't interfere with each other. So what's going to happen is when it goes up and down, these signals, this will try to fluctuate. But because of this feedback, can you remember when we're talking about second law, second Golden rule, we mentioned when you have feedback, it always try to minimize the difference. So when you try to fluctuate and move this voltage here up and down, this feedback circuit kicks in and try to make sure these two have equal voltages. Since this non-inverting input is 0, the feedback circuit means it's trying to keep this point equal to 0. So when it tries to goes up, it will try to pull it down. When it tries to goes down, it will try to pull up. So that way you are able to regulate the output voltage. Not output, you are able to create a virtual input, virtual ground to this point, so which makes less interference with each other. Right. So with that also we comes into another important conclusion, this particular one, that means you can use an op-amp to add different signals. If you look at all the analog circuits, they are mostly made from op-amps, right? So using op-amps, you can create small calculator, analog calculator, right? So if you want to input some volt, let's say you want to add 2 into 3, you add 2 volts into this input, 3 into this input, and you take the output using this V out. So your reading will give you the result of that mathematical operation, right? Good. තේරෙනවද? එතකොට ඇත්තටම analog calculator එක එකතු කිරීම කියන දේ කරන්න පුළුවන් මේ වගේ summing circuit එක, right? You can do it. Whatever the numbers you want to add, you give it as a voltage, and the result again you take it as a voltage. Okay? And another thing is, if you want, you can do a weighted addition. In here, every value has equal weight. They are all treated equally. But if you change the ratio between these resistors, you can make some inputs more prominent. They have a higher effect on the output. You can also make some inputs less prominent, or they have less effect on the output. So using this resistor ratios, you are able to make that change as well. So I'll leave it as a homework to rename this as R1, R2, R3, and this as RF, and to come up with an equation for the output. Okay? So then you will notice that they have a different ratio when you finally, different impact when you finally add them together. Right. Any question about this one?
So isn't the signal inverted here, the output one?
Yes, signal is inverted. You have to put a minus sign. Thank you for pointing out. There is a minus sign. It's an inverted signal. Right. Okay, now since we are at here, let's try to do something else. Can you create a circuit using one or more op amps to do the addition but without the inversion? So I want to have something like this. V out is equal to V1 plus V2 plus V3 without the minus sign, without the negative sign. Can we quickly design that one as well? Now I mentioned this one is mainly about designing circuits and creating it. So when you have such a idea, okay, let's try to create something that without inverting, you should think and design. You are free to use more than one op amp.
So is this possible?
Yes, it's possible,
Okay.
but you may have to use more than
This-
one. Okay.
This.
Okay, can you explain step by step what's happening?
The output we get in the previous one is fed back to another amplifier.
You are partially
Um,
correct. Partially correct, partially there's an issue. Now think about the second one, second op amp. Does it have a gain? I want to just invert the signal, not to change the amplitude of the signal, okay? So your V out 1 is, let's say, 3 volts minus 3 volts. V out 2 should be plus 3 volts. Are you able to do that using this setup? Okay, you are in the correct path, but you have to modify it a little bit.
Can you check my
Sure. Ketemu ayan ko siya. Campaign. Okay. Right. You are correct, but can you explain it again? Can you explain how it works? Your circuit.
output of the first op amp
Mhm.
due to the second op amp?
Mhm.
Since resistance in second op amp is equal, it working as a inverting amplifier with one gain. So only it inverted the signal.
Very good. Because you have to have the both resistors input and the feedback resistor equal, then this block basically inverts it. Right? Now you can see actually if you are looking at view as a building blocks, you can see there are two blocks. First block add things, second block invert it. Now let's add another step. Before going further, but I'd like to know the progress of other students. So Prasad and Sama, what about you? I didn't hear anything from you two. මොකද ඔය දෙන්නගේ තත්ත්වය? ඔය දෙන්නගේ මුකුත්ම feedback එකක් හම්බුනේ නැහැ. Sama, what about you? I'm not sure whether your line is clear.
Now, case there was a power cut issue. That's why.
Okay. Are you able to understand the concept we are talking about? දැන් කතා කරපු ටික තේරුණාද?
Yes, sir. It was clear.
Okay. Right. Uh, so we'll go ahead another step and try to build something a bit different. Let's say we have what shall we do? We have a load cell and a circuit. Now under the sensors, I will explain what is a load cell. For the time being, what you have to know is load cell is something that is able to measure the force. Okay? If you had used an electric balance or a scale, you are most likely using a load cell. They are commonly used to measure the weight. There are different types of load cells like pneumatic load cells, hydraulic ones, strain load cells. They mostly change the resistance depending on the applied force. So that is what a load cell is. So it basically changes the resistance. But to make this question easier, I am going to assume your load cell is coupled with something else. So you get a voltage output. Original ones usually you have what you have is the resistance. We usually use something called a Wheatstone bridge to convert it to voltage. Assume for the time being, it has already been done. So you have something like this. Let's say this is the load cell. So this outputs a voltage. Higher the weight, higher the voltage. Right? So that means weight is proportional to the voltage. We'll assume that. But the thing is, let's say you want to measure something very big. It's so big, you have to have a platform, right? You have to have a platform. To balance whatever you are measuring on top of this thing, you have 4 load cells, one at each corner. Right? Now what you need to do is you need to have your idea is, or your requirement is, you have something to measure. So the weight is distributed among these 4 load cells. Right? And my final goal is, if the weight is larger than some value, I don't know, if it is larger than some value, 10 kilograms, I should sound an alarm. I should get an alarm. Right? So you have 2 different steps. One thing is, you can't use a single load cell output of a single measurement to calculate the total weight, because it's already distributed among 4 corners. So you have to add them up. In the next step, you have to make sure, next step, you are comparing with your threshold value. Right? If it is larger than some threshold value, you should sound an alarm. Right? That's the next circuit I want you to design. Can you do it? Now, I did not give you any precise values like what is the weight, or what is the sensitivity of load cells, things like that. But without the numbers, you should be able to design the circuit. Actual numbers you can design once you know all the specifications. So for this step, I want you to design it. Some kind of scale where you put a weight, and if the weight is larger than some critical value, it should sound an alarm. Right? So go ahead and try to design this circuit.
Sir,
Oh, Kian.
should we use some in amplifier or in a
Yeah, you can use some in amplifier. Don't use digital electronics, okay? Any analog component you can use. ඉවර කරපු කවුරුවත් ඉන්නවද? නැතුම් ඉවරද?
Yes, sir.
ඉතින් පෙන්නන්නකො. හොඳයි. Right, now he had done it using 3 blocks. Right. That's good. You have the first block where you add the signal. Second block where you convert it to a positive signal. Third block where you compare it to a reference voltage. This is good. But if you want, you can make one extra improvement. Pratham, do you think you are able to concatenate or join the second and third op-amp, or maybe lose one of the op-amp altogether? What do you think?
Sir, not clear.
Now, you have one op-amp in the middle,
Yeah.
which convert your negative signal into positive voltage, right?
Yeah.
Right. But do you need to do it? Can your comparator compare negative signals?
Yeah. We should change the supply voltage in third op-amp.
Okay, I'll leave it for you to try. But remember, when you are giving a signal, you don't have to always compare it using the non-inverting input. If you want, you can compare it using the inverting input as well. And also, depend if you have something like a LDR or a thermistor something, there are two places where you can connect. Either you can connect it to the positive rail and the input, or you can connect it to the negative rail and the ground to the input. So that's another way of changing. Now here we don't have a resistance, variable resistor, so you can't apply that one. But if you want, you can think whether you can simplify it or improve it further. Anyway, your idea is good. Now I think you are getting hang of the thing I want to tell you, right? Now you are learning how to add blocks and come up with a little bit complicated circuit, right? Okay. Harini, what about you?
I have similar type of circuit.
Similar circuit.
Yeah, so we can address diode instead of that voltage divider.
You mean a Zener diode?
Yeah.
Yes, that will be more precise because that will make the comparison independent of the supply voltage. That's a good improvement. Other two, Sama yanit nama ivarada. Sam karna. Sama, good. Okay, you are halfway through. Sama ahenawada.
Yes, sir.
මේක තව කොටස් ඇඩ් වෙන්න ඕනද මෙච්චරයිද?
Add වෙන්න ඕනේ සර් මම comparator වෙන කොටස විතරයි යන්නේ.
හරි. චුට්ටක් ඉක්මනට අඳින්න බලන්න. Hurry, we will move to the next section until it is done. And those who haven't finished, please try to complete them when you have the time, right? Otherwise, you won't get that experience. When you are doing the circuit design yourself, only then you will get an experience of how to handle things. Right, now I'm going to share another one. This particular circuit. Now I want to make it easier for you guys. So I'm making all the resistors equal. R1, R2, R3, and R4 all are equal. I want you to come up with an expression for the V out. This design is generally known as a differential amplifier. It's called a differential amplifier. It is a very common thing that's used in many circuits. Before we dive into what it can do, I'd like you to find it out yourself. So come up with an expression for the V out. You can use R1, R2, R3, and R4 as equal values, right? That way it will help you simplify the circuit, right? Go ahead and give it a try. If anyone is finished, please let me know.
So can we take R1 and R2 equal?
Yes, that's why I said here.
Okay.
All of them are equal.
So take when V1 plus V2. Hello. කරගත්තද?
V2 minus V1.
Oh, that's a very straightforward scenario, right? Because if you take VA, that's the mouse. VA, let's say VB, If R2 is equal to R1, we directly have something like V2 divided by 2, right? Because this is in the center point. This is grounded. And VA, we can take it as V1 minus V out divided by 2. We also know VA is equal to VB. So we end up with V minus V out by 2. V2 divided by 2, these cancel out. V out is equal to V1 minus V2. Right? So this is a little bit similar to the open loop case. That means without any feedback, but in the open loop case, you have a gain, right? That means signal is amplified. It is more or less suitable for the comparator. But here we have a control. If you use all the resistors equal, we get directly the output as the difference between the voltages. By changing the ratios of R1, R2, R3, and R4, you can decide what kind of weight you want to have for different inputs. In general, this is known as a differential amplifier. It amplifies the difference between the signal. So it's easy for you to understand. It amplifies the difference between the signal. Earlier, we learned it's something similar to addition. So if you look at in the mathematical term, this is the difference or the subtraction. But rather than saying a subtractive amplifier, we call it as a differential amplifier. Can you think of a place where a differential amplifier is used? Differential amplifier එක පාවිච්චි කරන තැනක් හිතන්න පුළුවන්. කොයි වගේ application එකක් අපිට පාවිච්චි කරන්න පුළුවන්? Any idea? So then let's talk about that. For example, if you're sending a signal through some lines, right? You're sending through some signal through lines, then there's a tendency or there's a probability that you will add up certain noise into that signal. Let's say you have a telephone line, not a digital one, let's say an analog one, a very long telephone line. You have a house here and you have your exchange center here. So throughout this path, there are various sources that can add noise. For example, there might be lightning, which will generate a huge amount of electromagnetic radiation, which will induce a electric field, sorry, voltage. And there can be certain other things as well. For example, in a vehicle, if when the engine is running, there's a spark plug, which can also generate a certain amount of noise. These noises will add up to this line, right? So you won't get a clear signal. So we always try to reduce the noise. There are different ways of doing it. One way of doing it is to add the shield to this particular line. Okay. If you look at a shield coaxial cable, you will notice there's a thin aluminum-like foil around the center line. In that, if you look at a coaxial cable, let's see if I can quickly show you an image. So this is a coaxial cable. Okay, it dropped. Okay, we'll find it later. So here you have a foil sheet. So that is one way we try to reduce the noise going through this one. And you also have something like this one, this braided shield. This is usually the ground connection, right? So that we will try to reduce the noise in that way. Another way we can do is this: we can change or twist the wires of data going, sorry, in a circuit in sense where the voltage, you need to have a closed circuit to send the signal, right? So from left to right, you send the signal and you get right to left from the returning signal, right? So if you especially look at network cables, okay, now let me put that image as well. These are called twisted pairs, right? So again, you can see there are a pair of wires twisted together. The idea is if you generate if you're sending a signal through, let's say, this blue wire, a similar current should come back through the returning wire, which in case the white and blue wire, right? According to Kirchhoff's law. So any electric field generated through that signal will cancel out from the returning signal because they are twisted and have the same strength, right? So that's another way. But all of these things are related to the transmission lines, right? The actual physical build of the physical build of the communication path. On the circuit side also, we can do certain improvements. That's why the differential amplifier can be useful. The reason is in the differential amplifier, you are only amplifying the difference. Assume you have some kind of interference happening. Let's say there was a lightning and it generated an electromagnetic wave. Now both of these wires are very close to each other. So whatever the voltage generated in the first wire will be closely or roughly equal to the second wire. So if you're sending signal like earlier, let's say your first wire, let's say wire 1, wire 1, let's say 3 volts, wire 2, let's say it's 1 volt. So you are trying to send a difference of 2 volts. But due to the noise, you add, let's say 0.5 here, and since they are close to each other, the generated voltage will be the almost same. So now you have from the first wire, you have 3.5 volts, and the second wire, you have 1.5 volts. So if you are comparing these voltages to the ground line, you will notice there's a 0.5 volt increase. In other words, there's a noise. But if you just take in the difference, then still you get 2 volt, right? So the difference is the same because the noise is common to both wires, right? So if you have a data line like this, in this side, in the receiving side, in this receiving side, you can have a differential amplifier. So the signal you are receiving will reject the common noise and also amplify the signal. That's one application of differential amplifiers. Now, differential amplifiers doesn't need to always have op amp. So this is one of the common way of doing it. But simpler circuit, you can just use only 2 transistors, right? 2 identical transistors in back-to-back configuration. You can use it, but in this lecture, we learn how to create a differential amplifier using an op amp, right? Right. Now I'm going to draw another circuit and ask you to derive another one. Right. Before going to do that, do you know what this symbol represent? What is the component representing this symbol, circuit symbol?
Capacitor.
Yes, it's a capacitor. What is the purpose of a capacitor? How does a capacitor behave?
It store the charge for some time and then again release it.
Yes, exactly. The purpose of the capacitor